Welcome GeoTrig. This is a video on inscribed angles and circle equations. The essential question is, what do you think is the most important thing to remember about inscribed angles? Let's begin. So what is an inscribed angle? It's an angle whose sides are chords of a circle. So for example, this is the inscribed angle ACB, and both of these AC and BC are chords of a circle. Now there's this other word, intercepted arc. This is the arc with the endpoints and the sides of the inscribed circle. So it's kind of the arc that matches up with the angle that's inscribed. Now this has a really neat property which you really need to know. The measure of the inscribed angle is half the measure of the intercepted arc. So if you have the measure of angle B, this angle, that is going to equal half the measure of this arc right here. How can we use that property? Well, let's try this example. Find the values of A and B. A is this arc PT here. So A is arc PT. And, oh, you can't say P. Oh, it's just PT between that. There's nothing in between. Okay, so PT. And B is going to be this angle right here. That's angle PRS. Okay, so I know that angle A is PT. Well, this angle 60 is the angle that measures up the inscribed angle that corresponds to that arc. So the arc is going to be twice this angle. So A has got to equal 2 times 60 or 120. So A is 120. Now for B, this whole thing right here, this whole arc that corresponds to that angle is 120 plus 30, so 150. So B is going to equal 150 cut in half, so equals 75. 75. That's neat. Here's some other corollaries to that theorem. So if you have two inscribed angles that intercept the same arc, they're congruent, which makes sense because if they both match up this arc, they're both going to be half of that, the measure of that arc. So yeah, both angles would have to be congruent. And then corollary here. The area of inscribed by a semicircle is a right angle, which makes sense because a semicircle is 180 and a right angle is 90, and doubling this angle has to be the measure of that arc. And this last one, the opposite angles of a quadrilateral inscribed in a circle are supplementary. So add up to 180. That's kind of weird, but here's how it works out. So let's say we're talking about these two angles. Well, this angle right here, we'll do this one in purple. This is talking about this arc, and the one in red is talking about this arc. So the arcs that correspond to those inscribed angles are going to basically be the whole circle anyways. And the whole circle is 360, so the measure of those angles has to be half of that, which is 180. That's pretty cool. Next thing. So the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. Okay, so it's like you don't really have an inscribed angle, it's just the angle's kind of off there, but still kind of follows the same rules. So measure of angle C here, right here, is going to equal 1/2 the measure of this arc BDC. And the same thing over here. If you have a tangent line, it's like the inscribed angle's not completely there, but it still kind of follows the same rules. So in this diagram, the diagram SR is tangent to the circle Q at Q. If measure of arc MPMQ is 212, then what is the measure of PQR? So PQR is what I'm trying to find here. All right, how do I do that? Well, this arc here is going to be 212. That means this angle right here, we're following this last theorem, has to be half of that, so that's going to be 106. And these two angles have to add up to 180. So if that's 106, and they both add up to 180, the measure of angle PQR has to be 74. All right. Equation of a circle. This is the last section. So the equation of a circle is this. X minus h squared, y plus minus k squared equals r squared. And you do this when you have a circle. If we're putting this on coordinates, the center of the circle is at the HK. It's kind of like the vertex if we did a parabola. We're using h and k again. And then r is the radius of that circle. So this is, we can write an equation and we can actually put this on a coordinate grid, which is cool. So let's take this equation right here. X squared plus y squared equals 1. Well, in this case, you know your h is going to equal 0. There's nothing with the x. And then your k is going to equal 0. And then your 1 is r squared, so the square root of 1. So your r is going to be 1. So I can draw my origin, or my center of the circle right here. I'll label that 0, 0. And then our radius is 1. So how do you draw that? Well, I just start going one out in a few different directions. One out here, one out here, here, and here. And you know it's going to be a circle type shape. So you draw your perfect circle. Perfect circle. Oh, that's pretty good. That's pretty good for me. So that's it. Next thing. So going backwards on this, what is the standard equation? So write the equation of a circle with center 5, -2, and radius 7. So what's my h and k? H and k, h is going to be your x value, k is your y. It's like Hello Kitty. So hk, I figured that's the order. X, y, Hello Kitty. And the radius, r equals 7. So plugging it into the equation, it's going to be x minus h, so x minus 5 squared, plus y minus -2, or y plus 2 squared, equals 7 squared, or 49. 49. That's it. Let's try another one. What if I wanted to write the standard equation in that circle? Well, first you got to look at that and figure out where the center is. And the center is right there, and that's going to be the coordinates at 4, -3. So that means my h is 4, and my k is -3. And what's the radius of this? We'll just count out, go into one of the edges. And there's 3, so my radius is 3. And I can create that equation. It's going to be y minus, x minus h squared, so x minus 4 squared, plus y minus k, so plus 3 squared, equals 3 squared, which is 9. All right, let's try some examples. All right, let's talk about this. So one thing you want to notice, we have a diameter here, QL. That means to measure this arc's 180, and the angle that corresponds with that, the inscribed angle, has to be 90. So if this is 35, this is 90, y is going to have to equal 55. Now the next thing, we know that angle Q right here is 35. That means the arc JL, so I'm going to say JL as an arc, or the measure of JL, and not, I'll just call it JL, is going to equal 100, it's going to equal 70. Well, we got this angle that's forming off a tangent and one chord right here. If this is 170 for this arc JL, that means angle X right here has to be half of that, so X has to equal 35. And that's your answer. Next one. Alright, standard equation. Circle, your h is going to be 3, k is 5, and radius is 6. So your equation is going to be x minus 3 squared plus y minus 5 squared is going to equal r squared, or 36. Next one. Alright, standard equation. So center looks like it's right there, and the coordinates of that, if I'm following this, are 1, 4. So my h is 1, k is 4, and my radius following this is going 1 to 3, so radius is 2. The equation will be x minus 1 squared plus y minus 4 squared equals 2 squared, which is 4. That's it.